Hello everyone. In today's class, let us study how to find the derivative of the function a raised to x where a is some constant. Here we take f of x as a. According to the first principle method, derivative of some function f of x with respect to x will be equal to limit as h tending to 0 f of x plus h minus f of x divided by h. We need the term f of x plus h. So whenever we substitute x plus h instead of x or in the place of x, we get the term f of x plus h. Here we have the function a raised to x. I substituted x plus h in place of x. So this will become a raised to x plus h. By first principle method, we can find the derivative of a raised to x. So let us substitute all the values. Limit as h tending to 0. F of x plus h is nothing but a raised to x plus h minus f of x is nothing but a raised to x divided by h is there. Now this can be written as limit as h tending to 0. This e raised to x plus h can be written as a raised to x into a raised to h. Here minus a raised to x is there divided by h. Limit as h tending to 0. From these two terms a raised to x is common. So we left with a raised to h minus a raised to x divided by h. Okay. A raised to x we have taken outside, right? So this will become 1. Okay, no problem. Now let us apply the limit. So here a raised to x, the term as it is, so can be written as this as a log of a to the base e. Okay, log of a to the base e. Therefore derivative of a raised to x with respect to x is nothing but a raised to x log a. Okay, here now base is e. This is the derivative of the function a raised to x. Similarly, we can find the derivative of e raised to x also. So let us consider f of x as e raised to x. This is f of x. Then f of x plus h will be e raised to x plus h itself. So applying the formula of first principle, this is limit as h tending to 0 f of x plus h minus f of x divided by h can be written as limit as h tending to 0 f of x plus h is e raised to x plus h minus f of x is e raised to x divided by h. Again limit as h tending to 0 e raised to x plus h can be written as e raised to x into e raised to h minus e raised to x is there divided by h. So we can take e raised to x common from these two terms. Limit as h tending to 0 e raised to x outside, we left with e raised to h minus 1 divided by h. So this can be written as e raised to x into log e to the base e. Log e to the base e is nothing but 1. So we left with e raised to x because e raised to h minus 1 divided by h as limit h tending to 0, the value is 1 itself. So you need to remember this condition. Okay, this is the basic result we have used to this e raised to h minus 1 divided by h as limit h tending to 0. In this case also we have used the same result, e raised to h minus 1 divided by h. Here as h tending to 0, this whole limit will get the value 1. So we got this as log e to the base e. Log e to the base e is 1 itself. Okay, this is nothing but log e to the base e. Right. So like this we solve the problem. Here in the place of e we have a, therefore log a to the base e. Okay, like this we solve the problem. Or we find the derivative of a raised to x and e raised to x. In our next video, let us find how to find the derivative of log x. Okay, find the derivative of log x.